Welcome to the Irradiance CSP video tutorial. This is Block 2, Unit 4, concerning rotating Shadowband Radiometers. My name is Stefan Wilbert. Here we see one example for an RSI. It consists of the Pyranometer, the Shadowband, and the motor that rotates the Shadowband once every minute. Now, the Pyranometer is measuring global horizontal irradiance. During the rotation, the signal of the sensor is locked with a high frequency, and when the shadow of the Shadowband falls on the sensor, basically DHI is measured. If you know the solar position, DHI and GHI, you can calculate direct normal irradiance, what is necessary for CSP. The RSI is quite a common instrument used for solar resource assessment. This can be explained by the low requirement for maintenance. Usually, cleaning it once a week is sufficient, and this is not the case for highly accurate tracking systems with Pyranometers. There, cleaning the sensors every day is recommended. The RSI has quite a low power consumption, therefore it is possible to use a small PV panel and a battery as a power supply, and thus the RSI can be used at remote sites quite easily. This is not possible for solar tracking systems with Pyranometers, as their power consumption is quite high, maybe 50 watts. Okay, I now want to explain you how to adjust the RSI. So first of all, this axis has to show towards the south. Then the Pyranometer has to be leveled. Before you level the instrument, you have to unplug it. The water level is positioned directly on the Pyranometer. In order to be able to look correctly at the water level, it's good to have a step. So you can check if the water level really shows a horizontal position or not. It's not only sufficient to see the water bubble in the center of the water level, but you always have to have in mind that the water level itself has some error. This means that you have to rotate the water level by 180 degrees to control if the leveling is correct. To adjust the rotating Shadowband Radiometer, you need two Allen keys. Using these screws, adjust this axis. The small screw opens the axis for this tilt. First, I roughly adjust the position of the Pyranometer tilting with this axis. And as I said, for the fine adjustment, it's better to look at the water level from the top. Then I open the small screw, and now I can turn this aluminium tube. This procedure is an iterative procedure, so this means that you need several steps of alignment of this axis and the other one until you get to a sufficiently accurate result. As well as any other irradiance sensor, the RSI has to be calibrated. That's why you see so many RSIs here. This is another example for the rotating Shadowband Radiometer, the RSR2. It's a quite popular product, and it has the same principle of operation as the one I explained before. And here we see another example for an RSI. This one works with two Pyranometers, but it also uses the same principle of operation. All the examples I showed you use a continuous rotation. There are even rotating Shadowband Radiometers that use a discontinuous rotation.